Good. Thank you again, Amanda, for this opportunity to engage with the Ohio Food Policy Network through this webinar opportunity. As the title suggests, we're going to talk about changing climate locally, but also some global context as well, and then really unpack the impacts on farms and rural communities. One of the opportunities that I get within Extension is to engage people in their locations across the state and really put a personal face to the changes that we're seeing. We hear a lot about climate change that happens in other places. We hear about changing ice in the Arctic and the Antarctic regions, or warming oceans, and all of those things are interconnected, but it's important to understand what changes are taking place here in our own backyards so that we can make good, sound decisions about how to adapt to those changes and the reasons behind why we may want to mitigate some things to avoid even worse outcomes. So that's what we're going to talk about today. I get the luxury of talking about weather and climate all the time, almost on a daily basis, so I certainly consider this a blessed opportunity. So kind of as a little bit of, get this moving here, kind of a little bit more background. I grew up in Miamisburg, Ohio. So for those that are in Southwest Ohio, you probably know where that is. A lot of times when I go to Northern Ohio, they're not quite sure, but that's okay. We've got a lot of small towns across the state. It was a little bit smaller then, 40 years ago, than it was today. Certainly that whole area from Dayton to Cincinnati has grown up quite a bit. But when I was 3 years old, my family and we moved to Miami, Florida. And even at a young age, I was intimately aware of what tropical cyclones and hurricanes and tropical storms can do. And so anytime any storm got close to the shore, my family and I would go down and we'd watch the interaction of the atmosphere with the ocean. And that's when I became hooked on weather, just the power that weather has to impact our lives and our earth and environment around us. A couple years later, we moved back to Miamisburg, and then in 1988, of course, we had a major drought across much of the Midwest. This was, according to Time magazine, they call it the Big Dry, the drought of 1988. As I've been joking with folks, this photo on the bottom right is my retirement from farming. It was the last time I was on a tractor, but certainly I was interested on the impacts that weather has on agriculture and really the state of Ohio, and that's why I consider it a great opportunity to work with the state climate office as well. And then, of course, there are a lot of other impulses or events that happened in my life that kind of solidified my story as an atmospheric scientist. But Hurricane Hugo, as it approached the shore of Charleston, South Carolina, where some of my family were living, and John Hope, just the first hurricane specialist at the Weather Channel that just was really good about articulating those impacts and warning people ahead of time. And so I really took that to heart. But to kind of prime our talk today and discussion as we get into the end of the talk, I want you to think about and hope you can think about in your lifetime, have weather patterns changed? What have you noticed? And then also, think about questions like, how do I know? One of the things that's very important to think about when we're thinking about climate is that it impacts all of us, not equally, certainly, but our own experiences help shape our understanding of the changes that we're seeing, which means that if we're truly to adapt to the changes that we're seeing and mitigate possible future outcomes, then it's important that my experience blends with your experience as well to come up with solutions that work where and when they need to work. And so I think it's very important to have that established here at the very beginning. Now, kind of the punch to this really is in this statement. This is a statement that I would say sums up what we're facing is that our changing weather patterns directly impact both our economic and environmental sustainability. It's pretty clear that it has an impact on both how and where we spend the money and how we grow or expand as a society. And we are not certainly lacking for the environmental impacts that we see out there that challenge sustainability. And so it's very clear that these changing weather patterns that we're seeing are having a direct impact on both of these. And that's what I hope to convince perhaps, or share or highlight as we go along in this talk. And the way I'm going to start is really assessing this past year for the state of Ohio, and largely through an agricultural lens, but for those that aren't involved directly in farming or food production, but some tangential ideas here, just thinking about what you've experienced over this last year will go a long way. And we'll unpack that again a little bit more as we go along. So if we think from an agricultural standpoint, last fall we had some late planted small grains in the fall. We followed that up with winter injury due to wetness, water damage, some extreme cold. We came out of the winter with really a lack of forages across the state. We had poor stands in our forages, a lot of heaving in alfalfa across the state. As we went through spring and our planting windows grew smaller and smaller, we ended up with late or no planting of corn and soybeans for a large part of our state, especially across the northwest counties. You can hear about the impacts on fruits and vegetables that we had this season. Wetness duration and impacts on strawberries right here in central Ohio, or cold damage to peaches in certain parts of the state. And so what was clear as we came out and went into spring and into the growing season was a general disruption to that entire agricultural production cycle, that food production cycle as well, from planting and applications of herbicides and things, and now eventual harvesting. You know, the harvesting issues that we've been into when, you know, just a few weeks ago things looked pretty good in a lot of spots, and then you realize, hey, we're 4 weeks behind. You know, are we worried about an early season frost that may kind of limit what we're going into? If you go up in northwest Ohio, just a lot of tilled fields, bare ground. Weed pressure was intense, and some folks just decided to till up and deal with it that way. You know, difficult crop insurance and field management questions. Markets, you know, climate and the impacts from climate are sort of a stressor on things that we already do. And so all of these things come into play. And this is certainly what we've had to deal with over the past year. So I'll start, meteorologically speaking, looking at 2018. We're rounding out 2019 already, but I want to go back to 2018. If we look at 2018, the amount of rainfall that fell across the state, you know, we had 30 to 40 inches up here in northwest Ohio, up to 60 to 80 inches along the Ohio River. So we had some 60 to 70 inch rainfall amounts across in vicinity of the Ohio River here. And of course, that's well above average for the years. In fact, 2018 was the third wettest on our record. Now, our modern record goes back to 1895 here in Ohio, as a robust record from 1895 to 2018, or what we think of as modern observing records. It's the third wettest during that time, and the 19th warmest as well. And if we look at the top 10 wettest years on record since 1895, you'll notice that 5 of them have occurred since 2003. So out of this 125, 130-year time span, the 5 wettest years have all occurred since 2003, and with 2018 ranking third there. So it's been quite wet for quite a while, and I'll show you a time series of that in just a moment. So to break this down seasonally and how this impacted us from a weather standpoint, I could go back to last spring and bring up the variability that we had, but I'm going to start with the crazy fall, because we had a lot of variability there as well. And if you look at the fall rainfall, this was the third wettest fall on record since 1895, and September was the second wettest. You'll recall we had some tropical systems move a lot of moisture into the state. Hurricane Florence remnants and Tropical Storm Gordon brought those in as well. So very saturated already in the fall. And the other thing that happened, if you look at the top right, these are maps looking at the average temperature and how much different it is compared to our climatological normal, which is a great question. Right now, that's 1981 to 2010, as established as our normal value with the National Weather Service. It was certainly warm during the first half of the harvest season through about mid-October. And then we had this extreme switch to very cold conditions in November. If you talked to a lot of farmers, and those probably in the audience, some of you probably experienced the fact that you were having to wait until the ground was frozen in some respects to get out and harvest fields. So the wet conditions and the cold and the extreme switch really played havoc and really started this year's impacts, I would argue. So as we left fall going into winter, meteorologically we were expecting an El Nino season, which just means warmer than average sea surface temperatures in the tropical Pacific. What that usually means for our winter is we're drier than average. But this past winter was the 11th wettest on record for Ohio. You can see the comparison to normal in that upper right graph there. So a lot of places along and south of I-70 saw, 175 to 200% above average in terms of the amount of rainfall. So very wet conditions continued, but we did have some cold spells. You remember this polar vortex, extreme variability, extreme cold temperatures well below zero there in late January, followed by high temperatures into the 40s, close to 50 degrees. So the extreme variability and changes in temperature also having an impact on winter injury and crops and things, peaches and fruits and all of these things that can suffer damages during episodes like this. So then we get into the springtime this past year, and I labeled this rinse and repeat, but not equally across the entire state, right? If you look at the state, it wasn't in the top 10 warmest or wettest for March through May. But West Central Ohio and Northwest Ohio ranked 7th and 3rd wettest on record, respectively, for this spring. So the wet conditions just continued to play havoc. And if you look around St. Mary's, Ohio, for instance, this is a station that reported over 20 inches of rainfall between March 1st and May 31st. Normally, St. Mary's sees about 36 inches of rain in an entire year. So this was over half of their normal rainfall in just 3 months. And they weren't alone. There excessive rainfall across a large portion of Northwest and West Central Ohio, 20 to 26 days of at least a trace of precipitation during the month of May. So there were very few suitable fieldwork days, very few days for farmers to get into the fields throughout the springtime. And this continued. I mean, after we got through May, we ended up having our 5th wettest June on record. But if you look at our statewide precipitation ranks here, 124, these dark green here, indicates this is the wettest 12-month June through May on record. And certainly for Ohio and many states across the Midwest and the Central Plains, this was a very wet 12-month period. And you can see the divisional, what we call climate division rankings on the right-hand side as well. But we got through May, and this is what we were looking at. Again, I mentioned we had our 5th wettest June on record. So now we had back-to-back wettest 12-month periods on record. Parts of the state started to see some drying conditions, a little bit drier in July, but despite that fact, we still had now a 3rd consecutive wettest 12-month period on record from last August through this July. And in fact, even though right now we're sitting in moderate drought conditions across part of the state, last September through this August was the wettest 12-month September through August on record for Ohio. So this is, quite an astounding statistic here to think about 4 consecutive monthly 12-month above record wettest years or 12-month periods on record. So it's pretty astonishing. And this got me thinking about looking at some of the trends, and I'll start breaking down some of the trends here that are important. So if we think about spring, an important time to plant, and you look at the rainfall changes, and I'm just doing this since 1970 now, you can look at the frequency of rainfall for April through June. It's up about 3 to 11% depending on the month. During that season, we've seen 15 to 17% increase in the amount of rainfall that we see during our springtime since 1970. So that's about 1.5 to 2 inches on average more that we see during the spring now than we did in 1970, for instance. And what's really interesting, and I think the reason I'm interested in breaking it down monthly, is that April has really seen the largest increase, about 24% increase in that overall amount of precipitation that we see in April, compared to May, which is only 10%. And you'll notice in May, we've got highly variable conditions. And this is where I want to make the point. If you think about last season, I know it's hard to do, last spring, we had our 9th coldest April, warmest May. Divide those by 2. Climatologically speaking, it was an average spring, but we had such a shift, and May was so warm and dry that farmers were able to recover from a cold, wet April. This May was very, very different, right? We had the cold, wet April, but we also had the cold, wet May, which really set a lot of folks behind. And so this is kind of breaking down those spring trends and why I think that they're important to look at here. Now, of course, there's consequences for all that water, and this is an animation of the soil moisture as we were heading out of 2018 and through the first part of 2019. So you'll see at the end of this a large expanse of the Midwest, South Central, and Ohio and the Mid-Atlantic really entrenched in very wet soil conditions. And a lot of time we spent this past spring and into the summer, kind of in the top 1 or 5% of all saturation years in terms of the amount of soil moisture. And then you think about the runoff that we had and the runoff in Northwest Ohio. So through June, I think this goes into the first part of July on the bottom right curve. This is the cumulative amount of water or volume coming down the Maumee River there in Northwest Ohio at Waterville Station, the gauge. And this year was the highest cumulative amount that was coming down, that had come down at the Waterville gauge. So a tremendous amount of runoff occurring as well because of these persistently wet conditions that we saw really since last fall. I mentioned the field work days this May only being 7 really suitable field days for the entire month. If you look at our trends in field work days, and this would apply not just to field work, but gardeners and other things, if you're trying to get ready here, our April curve, this is the blue curve. Since 1995, we've lost 5 days of suitable fieldwork days in Ohio in both April, that's the blue curve, and October, which is the orange curve. So if you think about planting and you think about harvesting, we're essentially losing 10 days of that production cycle because of the conditions in the fields are not suitable for field work. So we're shrinking those windows down. We're having to do as much or more work over a limited amount of time, and that can be detrimental. Certainly technology and other things can help us overcome some of this loss, but it's important to note that these trends are pretty persistently going down for these two months in particular. So sometimes I fear showing this because it's pulling up all the bad memories, I think, for a lot of folks. The poor forage stands that I mentioned, a couple photos there in the middle, a lot of fields sitting with just a lot of water. I've been joking this spring, asking folks if anybody turned butterweed, that's the photo in the upper left, into a cash crop, because certainly we had plenty of that this year as well, and just all of the runoff. So a lot of challenges, I would say, happening throughout this season. But I also want to bring up something else that's also part of the story, and we're actually sitting in it right now. This is the U.S. Drought Monitor release as of this morning, actually, at 8 o'clock through conditions this past Tuesday. The beige area you see here across the northern Miami Valley and west central Ohio, the same locations that have been super saturated are now sitting in moderate drought conditions. So obviously, one lesson from this is weather can be variable. It can be highly variable. But what we've noticed, too, is a trend that despite the spring increase in rainfall trends in the fall, as I'll show you in a moment, our summer trends in precip are flat or relatively negative in some parts of the state. Essentially, we have drying trends during the summer, but wetter springs and falls. And that brings about a whole nother question about farm management. I don't think if you asked a farmer, they would much like saturated spring, hot, dry summer with saturated fall. When are you supposed to get work done, and how do we get our crops maturing properly and getting high yields? It's a challenge. And so I think this is a kind of a troubling combination that we're seeing in our trends, and it's certainly something that we're living right now when we've got some very dry conditions that have expanded across much of the state here just over the last week or two due to the very warm and dry conditions. So it's another management question to think about in terms of your small farm or even on a community scale. From a water municipality, the municipal water standpoint, going from too much rainfall to drought conditions, and the water supply and the water quality issues that go along with that. So that's kind of a journey, I think, through the last year as an example of the types of weather conditions that we've seen. And what I want to do now is put all of that into context and unpack this idea between weather and climate. I always like to show this slide because it's important that we delineate the differences between the two. When we think about weather, we're thinking about high frequency changes in temperature, wind speed, moisture. It's really caused by an imbalance of energy absorption at the surface of the Earth, and the Earth tries to basically shift that heat from the tropics to the poles. The effects of that are what we call weather, and they happen continuously. And so when we're living day to day, it's hard to see perhaps those cycles that we're seeing, or the variability or the patterns that we're seeing as well. But if we zoom out and we take a broader picture, and that's what I want to show here, this is just an example of a satellite image, satellite images stitched across the surface of the Earth, showing the motion of clouds for an arbitrary month here. And if you watch this for a few minutes, you start to see some distinct patterns. The fast moving storms across the bottom part of your screen, that's across the Southern Ocean. We see them across the region where we live too, but they take more of this north-south structure to them, and there's reasons why that's occurring. Maybe you see the clouds along the equator here that are sort of pulsing bright and then dim, and bright and then dim, going in the opposite direction. And over time, I mean, this is essentially what you're looking at are weather patterns, what we call weather patterns. We know that the weather generally goes from west to east across our region here in the Northern Hemisphere, particularly in the mid-latitudes, or where most of us live here. So over time, those weather patterns establish what we expect, right? The temperatures, the amount of moisture that we expect over a certain amount of time. And that really is what climate is. It's the slower varying aspects, the averages over longer periods of months or more. And some of you that may have joined us that have seen me talk previously, I like to ask folks to think about this image in the bottom right and ask yourself, what is this image? And it's kind of hard to see because we're zoomed in pretty close. But I'm going to play another video here. And in just a moment, I think most of you probably already identify a paw. And now we've got a dog, and the dog's walking along with the dog walker, right? Maybe you're out walking your dog this morning, and your dog has some natural tendencies. If it's hungry and it finds a wrapper, if it's got to use the potty and it sees a fire hydrant or a tree, it's got some natural tendencies that are going to drive the dog. But at any one time, that dog could be moving in the opposite direction that you're taking. But in general, in a couple minutes, you're still going to be in this area. And we base that on what we see, or the path that the dog walker is taking, indicated by the blue footsteps here. Now, the dog walker could be pushed off in another direction. Maybe another dog approaches or a car approaches, but it's not likely given the evidence that we see. So in this example, you can think of the dog as the weather, and you can think of the dog walker as the climate. And even though they can move in opposite directions at any one time, in general, they're moving together, right? So over time, the path that the dog takes, that mean path, is the dog walker. And you can think of weather and climate in that way. And I think it's just a really good illustration of that relationship. We know that the power of weather, and I like to use that term, is distinct, and often it's destructive. So one of Ohio's greatest weather disasters in 1913 was the major floods that occurred, with 6 to 11 inches of rain across the entire state. This was my hometown of Miamisburg, flooded here along the Great Miami River. We often come together after these powerful weather events, and we come together and we say, hey, we're going to build levees because we want to protect life and property. We come together after major tornadic destruction like we saw in the Northern Miami Valley just this past Memorial Day. If you think about the derecho that came along a few years ago and did a lot of damage with a lot of electricity out for weeks on end, powerful weather events certainly help mark our lives. We think about the blizzard of 1978, for instance, or the derecho or a tornado that happened. They're very impactful. And often we want to understand, how are these events changing? Are we increasing tornadoes or hailstorms or thunderstorms? And it's very difficult to do that because they occur over a small surface area. So detecting them and understanding their causes is a bit more limited than thinking about how is precipitation changing, or cold waves, or floods, or droughts. And that's what this graph is showing. We've got more understanding, and we can detect changes of some of the larger scale phenomenon a little bit easier. So I think there are good ways and bad ways to frame these weather events from a context of climate or climate change. We can't say, did a climate change cause a particular event to occur? It's sort of a bad question. It's better to ask from a scientific standpoint, are events of this severity becoming more or less likely because of climate change? Or to what extent was the storm intensified, right? To what extent was the storm in Houston that last week that dropped 48 inches of rainfall intensified by our changing atmospheric conditions, or Hurricane Harvey or Sandy or Dorian, or our overall precipitation patterns? Those are the types of questions that we want to ask. And if we think about the costliest weather disasters in Ohio, they are water related, right? Flash flooding and river flooding account for more than $200 million in rain related disasters. We have tornado disasters as well, which are a little bit harder to detect because they're smaller in nature. But the flash flooding and the river flooding are major destruction in Ohio. So I would argue that the face of our changing climate in Ohio is really centered around water. The power of water, the destruction of water, and how it's changing is very, very important. So to add some global context to this, global temperatures have warmed. This is the rankings. Basically, the graph you see on the left is how both our global land and ocean temperatures have changed compared to a 20th century mean, a 100-year mean, since 1880. And so you can see we were very cold in the late 1800s, early 1900s compared to the 20th century. We were up and down from 40 through 70, and then we've had this distinct warming trend since the late 1970s. And if you look at 2018, it was the fourth warmest on record since 1880. And again, just like with the wet conditions that we've seen of late, globally speaking, 9 out of the top 10 warmest years have all happened since 2005. 1998 is the other one that's in that top 10. So 9 out of the top 10 warmest years since 2005. And the map on the right shows the spatial changes in those temperatures compared to average. So at any one time, we might be cooler than average or warmer than average. If we look at Ohio here and we think about the 1930s, our summer records from 34, 37, these are our extreme summer high temperatures during the drought era, the Dust Bowl eras in the 1930s, right? But since 1970, we've seen this tone shift, this change in major warming happening across parts of the Arctic and the Antarctic as well, but also areas in between. Regionally, there may be some cooling areas, right? But overall, we see this large change in the temperature. Now, this is a little bit old because we're sitting in September, but I've been asking folks, about this year. For the U.S., this is the 41st coldest since 1895. We were so wet over such a large portion of the country that from January through July, it was relatively colder than average. But if you look in terms of the globe, it's tied for the second warmest on the globe. So this idea that what's just happening in our back door doesn't speak about what's happening everywhere, and that's very important to remember. But again, our experiences are driven by what we see, right? Our understanding of that. And so understanding the weather and climate and how what we're seeing in terms of weather doesn't necessarily describe the entire climate is a very important part of all of our discussion here. Now, warming temperatures have feedbacks, right? Temperatures go up. The Byrd Polar and Climate Research Center here studies about how glaciers and ice sheets change. That water melts, it runs off, it creates sea level rise. We don't have an ocean here in Ohio, right? We do obviously in the US, and folks along the eastern coast of the US are having to deal with the rising sea level. Here in Ohio, our impacts really come from the rising temperatures, but also the amount of water vapor that's in the atmosphere. You probably heard warmer air holds more water. While scientifically not exactly correct, but that's the idea, is that as we get warmer, we have more water vapor in the atmosphere. And the water vapor is also a greenhouse gas. It contributes to the warmth of the atmosphere as well. We see a lot of that global evidence. I mentioned the sea level rise. This is just a graph showing the sea level rise observed since the 1990s. The bottom right, we get a lot of sunny day flooding. This is Miami, where you get a little sea level rise, which we've had, but the high tide comes in, and then you get a lot of inundation of water inland, right? Just over a small vertical change of the sea level. On August 2nd, the extreme warmth this year across Greenland. We had the equivalent of 4.4 million Olympic-sized swimming pools of water melt across the surface of Greenland and drain, right? A lot of that water draining off and contributing to that sea level rise concept. So this is an evidence of ice that's melting in our cryosphere, in our icy regions of the world. But again, what I'm hoping to drive home are the connections, because even though these locations seem distant, they're a symptom and a sign, and they have connections to changes that are taking place elsewhere. And if we look closer to home and we think about the regional climate trends, we think about, you hear a lot about the wildfires this season in Alaska and California last year. This is the personal face of changing climate in the Western US. Across the Southeast, we think about the intensifying, the more frequent and more a longer duration of North Atlantic hurricanes, the Cat 4s and Cat 5s, and their impacts possibly along the Southeast coast. And then you get into the Midwest and the Northeast, and our signs really all point to this extreme precipitation, the heavy downpours that are increasing nationally and especially over the last 3 to 5 decades here across the Midwest. So we think of climate change as a threat multiplier, right? It makes everything we do harder to do. If we're a planner, we're a farmer, if we're building roads and highways, if we're planning those, all of this, if public health, the threat from climate change is a multiplier on what we do. So to break down the changes that are happening a little bit more here closer to home, this is the annual temperature change now compared to early 20th century across the US. You'll notice in Ohio, it's about 1.5 to 2 degrees in places, but 1 to 2 degrees Fahrenheit. Doesn't sound like a lot, does it? When I ask people, does 1 or 2 degrees sound like a lot? Because we know our temperatures rise much more than that in a given day. And that's the difference between weather and climate. We're talking about changes of a degree or two over a very long period of time. Just that, our temperatures can go up 20, 25 degrees in a day. If you think about the differences here in Ohio of a climate where we have ice versus a much warmer climate, we're talking ice, maybe we're talking 10 or 12 degrees Fahrenheit cooler than today, versus, where we've got an ocean perhaps that's fairly close, and we're talking, 20 degrees warmer than today. So there's a big difference between the weather and the climate aspects. The other part of this is winters are warming twice as fast as our summertime. So the seasons aren't changing equally as well. In addition to the seasonal changes, if you increase your mean, by theory, if the distribution of temperatures stays the same, then you should be seeing an increase in your tails as well, right? The record heat. And if you look across the US, we've seen an increase since the 60s of the record high ratio versus record lows. But more importantly, I want to draw your attention to the column here, the table on the bottom, because this is the last 730 and 365 days across the US in terms of the daily record highs versus record lows. So the far left column, these are the record highs versus record lows. So we are outpacing, but they're fairly similar. Remember, we had that colder start to the season, or colder start to the year this year. But I want to draw your attention to the middle columns. High minimums, that means overnight lows that stay abnormally warm, and low maxes are daytime highs that stay abnormally cool. And you can see the numbers are much larger, and they're much larger than the percentage of the total. So what's happening to keep our overnight lows higher and our daytime highs lower? Okay, we can look at that. And what we can do is we can compare how the temperatures have changed, those maximum temperatures that have changed since during the warmest part of the year, the high temperature change now compared to the early 20th century. And that's what you see on the right-hand side, pretty much along the 100th meridian here, the Great Plains through the Midwest. We see cooler daytime maximum high temperatures during the summer. And that's because we've got more water vapor in the atmosphere, which limits the amount of heating we have during the day, but it also increases your overnight low temperatures. Last night here in central Ohio, we were in the upper 60s to low 70s, right? The humidity creeping back in. This is the idea and the concept. So last year here in Columbus, we had 12 nights where we stayed at record overnight lows, but that were warm, if that makes sense. So more water vapor directly tied to decreasing summertime temperature, increasing overnight temperatures, and also more water vapor, meaning increasing winter temperatures as well. And a lot of this has been tied to agricultural intensification since the Dust Bowl across the Midwest. We have a lot of crops in the ground, corn, for instance, that can draw up soil moisture, evaporate that into the air. That's more water vapor. It keeps the daytime highs cooler during the summer, the overnight lows a little warm, but the humidity also rises, the amount of water vapor that's in the atmosphere. So if we think about our temperature impacts, we think about additional stress on humans and livestock. If you're a livestock owner and you're thinking about adequate cooling needs, might not be 100, but 94 is hot during the day. And if I only cool off just below 80 during the summer, that's not a lot of relief, right? Especially with higher humidity. If we think about pollination and grain, impacts from overnight lows that are staying very warm and how much energy is being used by crops, for instance. Shifting growing zones. Is there an opportunity here to grow more subtropical varieties versus temperate varieties? Increased weed pressure, insect pressure, and potential diseases. If it's wetter for longer, a lot more ideas about mold and fungus and things. Weed pressure, certainly. We've got an environment that weeds can really thrive in, and multiple generations of insects. All of these come into play with our temperature impacts. We think about other concerns about disconnects between pollinators, birds and insects and other wildlife, that the whole cycle is disrupted because of the timing. Invasive and non-native plants and their ranges that are expanding into our areas and really thriving here. So these are all concerns from a temperature standpoint that really play havoc with kind of the environment that we have right now. And then, of course, if we think about that water, and I know I haven't left too much time and I really want to hit this, but if we look at the annual and seasonal changes in precipitation, we're talking an increase of 4% of our annual precipitation across the US. Here in Ohio, since 1901, we've gone up 5 to 15%. That means 3 to 4 more inches per year that we're seeing now than we did in the early part of the 20th century. A lot of this is driven by our fall trends, up about 15%, but I showed you the spring trends earlier, as well as summer precipitation increasing in the north, but kind of drying out over more the southern part and a more expansive part of the state as well. And also the intensity of those rainfall events. I'm going to skip this one and actually go to this to talk about it. If we look at our changes that have happened in terms of our Ohio's annual departure from average rainfall, ups and downs here. And if you follow the black line, it's like the 10-year mean. Okay. And then we get into our last decade or two, and this has been the wettest decade or two on record for Ohio. So the amount of water we're seeing now is more than we've seen during our lifetime, our parents' lifetime, and really our grandparents' lifetime. So we're seeing those challenges really come through with the precipitation. If we look at the extreme events, those events where we're comparing how often do we see rainfall, for instance, above 2 inches. Since the mid-1990s, we've seen a large increase, a shift toward heavier rainfall events. And if you look at the other 3 peaks in the record back to the late 1800s, there are 3 years, 1913, 37, and 59, that fall within those peaks. And those were all major flood years. In other words, flooding is much more than just precip. It's how we store water, how does it flow, what kind of development do we have. But what this graph is telling me is we're under a persistent flood threat. So our need to plan for that water is increasing. And it's been around really for the last 20 years of these intense precipitation rainfall events. As an illustration of that, you can look, I've looked at a suite of stations across northern Ohio and then broken out how the magnitude of the precipitation has changed since the mid-1950s. So you can see events greater than 3 inches, 2.5, 2 inches, events greater than 1.5 inches, and you see this distinct trend since the 1960s of an increase in the number of events where we're seeing more of our precipitation come down in these more intense rainfall events. Okay, so this is not just the amount or the season, but also the intensity of the rainfall. So the risks from this extreme precipitation is quite immense, right? From damage to water, infrastructure and changing floodplains. Think about our roads, our flood walls, our dams. Twice this year, I've been stopped on I-71 with water completely covering the highway. So we have to ask questions about, are we building our infrastructure that can handle this type of rainfall? The health risks associated with floods, exposure, non-point source pollution, increased transportation issues, all of these are part of these risks that we're seeing. And this is just like a snapshot of the examples. And this is a great question from a farming and agricultural standpoint. This event up here in the upper left is 5.5 inches of rain in northern edge of Arcanum a couple of summers ago. How do we build resilience to 5.5 inches of rainfall in 2 hours? That's a lot of rainfall. It's a lot of water. And I'm not sure that there's an easy answer to that, a cheap answer to that, but these are the types of questions that we need to be asking ourselves. How do we better prepare our infrastructure? A lot of conversation, centered in the state around water quality, which is very important. But these extreme precipitation events are part of this, with a huge amount of erosion over a very short period of time. And certainly farmers don't want nutrients running off into the waterways. They're better, they're more profitable when they remain on the fields to help the crops. And so these extreme precipitation events are really challenging us in a lot of different ways. So I like this statement, this summary statement from the National Climate Assessment, which is essentially that the degradation of critical soil and water resources will expand as these events increase. We think about excessive runoff and leaching, soil erosion, degraded water quality. These are things that aren't future problems. These are things that we're seeing right now. These once predicted impacts are really happening today. We think about abnormal weather events, climatic conditions that are really forcing all of us and forcing farmers to adapt to challenges that are affecting both productivity and waterways. We have to do it in a way that's economically and environmentally sustainable to come up with ways of building resilience. Because if you look into the future using our best tools and we think about our temperatures, we're talking about climate that's 4 to 5 degrees warmer than what we expect now. We're talking about rainfall of 3 to 5 inches of rain, more rain per year than our 76 to 05 climate, or that climate that we think of now. A lot of the warmth coming during our overnight lows, but also as our hydrologic balance shifts, where we can go from extreme wet to extreme dry conditions that are really driving up temperatures that we're going to see next week in the low 90s during the first week of October, for instance. These are the types of weather events that come along with the climate regimes that we're seeing. So it may not hit 100, but we're talking 20 to 30 more 90-degree days. We're talking nights, 10 to 15, 20 more nights where we don't fall below 75 degrees. How does this change agriculture? How does this change our management of our small farms and communities throughout the state? Where our nights don't drop below freezing in the winter, 20 to 30 fewer nights, okay? If it's wet in the fall, we're waiting for the ground to freeze, but the ground never freezes. When do we get the crops off? These are all good conditions, are good questions to ask. And of course, we expect the heavier rainfall events. And again, this seasonal redistribution of precipitation, where our typical, what we think of agricultural off-season, the spring, the fall, the winter, where we see more rainfall, but during the growing season where we see less of it, driving home the idea and the concept of needing some questions around water storage. So I ask you, what if this is our new normal? It's not such a stretch of the idea to think about this past year in terms of a new normal. If you think about all of our long-term changes, the observed changes that we're seeing are exactly what we've seen over the last year or two. This is a weather example of a general change in our climate. So what we project is an Ohio climate that we think of today by 2030 looking more like a Virginia winter, more like a Southern Illinois summer. Or by the end of the 20th century, looking more like a North Carolina winter or an Arkansas summer. What is farming? What do small farms look like? What do communities look like when we've got that type of climate here in Ohio? So to wrap things up, I think what's important are for small farms, large farms as well, communities, the university researchers, the commodity groups, the CCAs, USDA, NRCS, all of us thinking about soil and water health and the nexus of that. If we think about if we're going to adapt to these changes and we want better, healthier soils and water, well, no crop cover crops, no-till intensity, things like that can have impacts positive on both the soil water quality, but also building up that water storage capacity. So obviously there are a lot of potential solutions and not one size fits all for every farmer, but thinking about how do we decrease the risk of erosion in extreme precipitation events. What conservation practices can we take that really slow the progress of water from our fields to our streams, but also improve that soil quality and capacity as well, the soil structure. And so I think a lot of innovation may come in catchments to cope with projected rainfall and evaporation rates, and different things from a horticultural standpoint that we can think of in terms of irrigation or different hybrids or netting to shade crops and things like that. These are all important questions that are on the table. There is what I think is an excellent resource for small farms in particular, but any farm. It's really a workbook from the USDA looking at how to respond to the climate variability that we're seeing and changes in the Midwest. And they're wrapped around several strategies, but a couple I want to point out. I mentioned, thinking about fundamental functions of soil and water, but also strategy number 5, managing farms and fields as part of a larger landscape. I think this is an opportunity for farmers to think not just as their field as an isolated field. And I think a lot of farmers feel this way, very passionate about the environment, but it's part of a larger landscape, part of the larger township, the community that really rests on the farmers and the productivity that we're seeing. But thinking of these things as, if I limit the amount of water that's on my farm, well, that's obviously going to affect our neighbors, and it's going to affect everyone who ultimately lives downstream. We all live downstream, and so we all have a part in this. And I think this resource here with the Adaptation Resources is a good place to start. So I've gone a couple minutes over because I know we want to ask questions, but I do thank you for your time. And again, if you want to reach out, there's my contact information, and I'd be happy to take any questions that you have. Thank you so much.
Thanks, Aaron. There was one question submitted by Rachel, and it was, I think, a few slides back, but she was asking, what's the time frame? Is this the total number of events per month?
Let's see.
And I can go ahead and, Rachel, I've unmuted you so you can talk if you want to clarify that question.
Okay, hi, can you hear me?
Here. Yeah.
Yeah, so it was actually maybe a little further back.
Okay.
There, right there.
Yeah.
Number of events with precipitation greater than 2 inches. So is that like in that time frame from 2010 to 2014?
Yes.
That's 1.25.
Yep. So a little bit confusing.
Whole time frame?
Yeah. So the idea is that, if you look at any one location, the way it's kind of a probability thing. Across the state, at any one location, the number of events that exceed 2 inches has gone up. We've seen that stepwise change. So what that means is basically we often, even in the historical period, for any single one location, we don't see a lot of events where they're above 2 inches, right? But you're hearing about it more and more because it's occurring over more and more locations. Just a few days ago, we had 2.4 inches fall in northwest Franklin County. You only had to go 10 miles where it was less than it was basically a trace of rainfall. That's what we're talking about. So if you're just looking at the stations, you have to remember, we don't have stations at every single location across Ohio, but the stations that we have, the frequency is going to come up pretty small, right?
Got it.
That's why the number is so small.
Thanks. Yeah, because I was considering my own farm.
Yeah.
In that time period, there were definitely more than 1.25 events with 2 inches.
Absolutely. I was thinking about Pickaway County in June had 3 events over 3 inches. I was
right. Yeah.
Just south of my house. So yeah, absolutely.
Thanks for that clarification.
You're welcome.
And then there's 2 questions from Emily, and I'm going to also go ahead and unmute her in case she wants to talk. But she said, am I correct that you classified water vapor as a greenhouse gas? And who is working on climate mitigation in agriculture within Ohio State?
Yeah, so absolutely. I mean, if you think about greenhouse gases, the two largest ones are actually, and I have some, I'd like to share these, but if I can, I've got some extra slides to look at that. So if we think about our greenhouse gases, the two largest are water vapor and carbon dioxide. And the way it works is these greenhouse gases, when the shortwave radiation comes in from the sun, they're not impacted by that energy. But as soon as the Earth gives off long wave infrared heat, essentially, water vapor and carbon dioxide and methane and nitrous oxide, which are also greenhouse gases, absorb that energy and the temperature goes up. So because we have water vapor and carbon dioxide in the atmosphere, our atmosphere is 60 degrees warmer than it would be without those two gases, okay? But what we've seen is an increase in the water vapor of about 5 to 10% in the last 50 years. And of course, our carbon dioxide, when we started directly measuring it in 1958, it was at 310 parts per million, and now it's over 415 parts per million. So both of those increases in those greenhouse gases mean more of that energy that's being given off by the surface is being absorbed there in the atmosphere, and then the temperature rises. So there's a direct comparison between changing the atmospheric composition of the gases in the air, which include water vapor and carbon dioxide, and increasing our temperature.
So is the increase in water vapor attributable to CO2 emissions increase?
Well, there's a warming feedback. So as the temperatures go up and evaporation takes place, then more water vapor is evaporated into the atmosphere.
Makes sense. Thank you.
Right. So there is a direct feedback there. So they're both going up, but there's a positive feedback with the temperatures increasing and the water vapor, but the temperature is increasing also because of the carbon dioxide increasing in the atmosphere.
Sure.
So the second part of the question is there are some mitigation, things, discussions, and my mind's blinking all of a sudden on a couple of the researchers looking at carbon capture and things like that at this time they may or may not be cost prohibitive, but that's where the research is and ultimately where the policy questions will lie. We do know that increasing agroforestry can have a good impact on CO2 drawdown. We know that adding cover crops, although we could cover crop a lot, right, and still not draw down everything that we have, is also important for carbon and drawdown. If you're familiar with the work with Ratan Lal, thinking about this is why I think soil is important. I mean, he's assessed essentially that the soil capacity to store carbon that we've had in the atmosphere is about 10% of our current emissions. It turns out to be like 20 petagigatons, right, of CO2. So the better we treat that soil from a fertility and from a health standpoint, less tillage, more cover, the more of that CO2 is being able, that carbon is able to be captured in the ground, and it has mutual benefits. So it's a no regret win-win kind of situation.
And there's a strong interest among some members of the Ohio Food Policy Network, and certainly within the Ohio Ecological Food and Farm Association, to pursue soil health legislation in Ohio to promote those practices. It's something that is being done in many states around the country. So we're very interested in those researchers and specialists that can advise on, the best soil health measures to implement.
Yeah. Kevin King is someone else that comes to mind. He does a lot of edge of field studies with nutrients and runoff loss, but also, impacts of cover crops on whether it increases or decreases phosphorus and things like that as well. So, there's definitely research that's taking place, and I think there's a lot of, and for good reason, a lot of emphasis on our soils, and treating our soils better than perhaps we have in the past.
There's another question that was submitted anonymously, Aaron. I don't know if you can see it in the Q&A box, but I'm going to go ahead and read it. It's a little bit long. It says, I'm pretty sure the answer to this is no, but I'm asking anyway. Are there any localized atmospheric soil weather benefits of cutting greenhouse gas emissions? In other words, if the state of Ohio went carbon neutral, would there be any climatological soil weather benefits for Ohio? If not, given the collective action problem, is our best focus on adaptation strategies while waiting for the large national, international players to move?
What a great, fantastic, loaded question. Uh, so I've been thinking a lot about this because the question of personal actions has come up a lot recently. There are a lot of things that get attention, and it's good to have attention when we're thinking about energy efficiency and less use and things like that, which individual actions are very important for this. And then from what you mentioned, if we're thinking about the atmospheric soil benefits, I mean, ultimately a gas like carbon dioxide doesn't stay over Ohio, right? It's circulated throughout the world, and mainly here in Ohio, it's emitted right into the atmosphere and stays in the northern hemisphere, but it has a global impact. So you're right. If we can bring that question back up. Did you push it? Yeah. So yeah, I mean, if you think about localized soil weather benefits of cutting greenhouse gases, the benefit is for it's for the larger society kind of thinking. So then you ask, you're right. You know, if we're focusing, you'll notice a lot of my talk is focusing on adaptation strategies because at the ground level and from a personal standpoint, we're already being impacted. So we have to learn to better adapt to the changes that we've seen and that we're expecting to see. And then this last piece about large national, international players to move is very interesting because while all of the individual action is great, and I think that that's important that we take those actions, I don't want to undermine that. I think there are larger transformational changes that need to take place that I would argue that are already taking place from an agricultural standpoint. If you think about, for instance, the emissions of agricultural in Ohio now down, or in the US, you know, down to about 9% of the total emissions from our country, where it's much larger outside of the US. That's an indication that those efforts can work here. But I think it's an opportunity to use ag in the US as an example for agriculture throughout the world. What does that mean? Well, ultimately, that means you've got to have policymakers that are recognizing what's happening and then actually use that information to lead into kind of a more of a societal change. And ultimately, that depends on how you feel and what you vote, right? I always tell people there are two ways where individual actions can really impact. You know, if you're in the voting booth, voting for those that align with the values, if your value is that climate policy is important, then that's what you should vote. And the other one is supporting organizations, supporting industries that understand that change is transformational and on a larger scale have to happen to really get a societal shift here. And it's not an on-off switch. That's the last point of this I want to make. It's not as if the actions we take now prohibit detriments or poor outcomes in the future. It's how much can we limit the damage for the future? That's the questions that we're really asking right now. Hopefully I've answered that, Brian. Amanda, you still there?
Sorry, I had myself muted.
That's okay.
So Brian is muted. He wasn't able to respond. We have one more request from Matthew. He said,
Sure.
Would you please put the small farm resource guide and link from the very end of the presentation back on the screen?
Oh, absolutely. Let's do it. Maybe. Here we go.
All right. So it is a little past 1. So to be mindful of everyone's time, we'll go ahead and wrap up for now. If you have any additional questions, Aaron said you can reach out to him. Again, this will be recorded and archived. Should be out on the listserv in the next few days. And then I wanted to just remind everybody that the Ohio Food Policy Network Summit is happening in October. I just put a link into the chat box for where you can find out more information about that and register. We will not have a virtual convening next month because of the summit. And so I'll send out a long list of link of all the archived videos from this year if you'd like to catch up. And again, thank you, Erin, for the presentation. I think I can speak on behalf of the group and say that that was pretty wonderful. And I think I learned a lot, and I hope others enjoyed it as well. And then thank you again, and we'll see everybody in October, hopefully.
Thanks again, Amanda.
All right, bye, everybody.